all know the phrase that too much of anything is bad and balance is key. Let's connect this to our oceans. Understanding water chemistry allows us to measure the several parts that keep our delicate waters balanced. One major imbalance occurring in our seawater is a process called ocean acidification. It is calculated from the pH scale, a scale that measures how acidic or basic any water-based solution is through the inverse amounts of hydrogen and hydroxide ions. The scale goes from 0 to 14, where 7 is neutral, more than 7 is basic, and under 7 is acidic. More hydrogen ions equals more acidic, and more hydroxide ions means more basic. Ocean acidification occurs from the increased presence of hydrogen ions that comes from chemical reactions between CO2 and H2O. It creates a carbonic acid, but since the acid is so weak, it disassociates into smaller ions, hydrogen and bicarbonate. The CO2 that's absorbed from the atmosphere comes naturally from fires, volcanoes, decomposition, and so on. It can also come from human activity like burning fossil fuels, deforestation, car emissions, and so on. Our ocean is like one big carbon dioxide sponge that absorbs 30% of any present amount of CO2 in the atmosphere. The increasing amount of human activity is pumping an excess amount of CO2 into the atmosphere and balancing the pH. The ocean's current pH is 8.1, which is not acidic, but this is a decrease from the original pH of 8.2, which occurred within a span of 200 years, 100 times faster than the normal rate of ocean acidification increase, caused by the pumping of 2,000 gigatons of CO2 into the atmosphere from the beginning of the Industrial Revolution to now. While the pH decrease may seem small, the pH scale is actually logarithmic, meaning that small differences are actually big changes. This change is equivalent to a 26% increase in acidity from a 0.1 unit decrease in pH. Also, the extra available hydrogen ions begin to bond with carbonate ions and create bicarbonate. The lack of carbonate decreases the amount of calcium carbonate made. This is a mineral used by calcifying organisms like pteropod and coral to build shells and exoskeletons. Lack of this mineral makes it harder for the protective layer to be made, making them weak and easily damageable. Higher ocean acidification also makes seawater corrosive, which can dissolve shells. While this process may be quite damaging, it is not the first time it has happened. 55 million years ago, evidence in the Paleocene-Eocene boundary shows the mass release of CO2 over thousands of years. Its steady rate allowed marine life a better chance to acclimate versus our current situation. Researchers at IPCC say that atmospheric CO2 levels could be 550 parts per million by 2050 and 800 plus parts per million by 2100. The pH will decrease by 0.3 to 0.4 units, 150% increase in acidity. Oceans will become undersaturated with calcium carbonate, and a predicted 1/3 of marine organisms will become extinct. Our oceans are like lungs. The more we pump toxins into them, then the increased chance of them collapsing. Our oceans take care of us, but we take care of it.